Hello everyone. I Sindhishri MV, Assistant Professor, Department of Mathematics. Today I am going to take the last module, the linear algebra. Subject code is 18MAT101. In that I am going to explain the eigenvalues and the eigenvectors of a square matrix. First, I tell you the definition. Consider the square matrix A, then there exists a scalar lambda which is real or complex and a non-zero column matrix X such that Ax equals lambda x, then lambda is called the eigenvalue of the given square matrix and x is called the eigenvector of A corresponding to the eigenvalue lambda. To find the eigenvalue and the eigenvector to the corresponding square matrix, first we use the analytical method. So we have the working rule for the analytical method. First I consider the square matrix of order 3 cross 3. So first procedure, you have to find the characteristic equation using this formula, determinant of A minus lambda I equal to 0, or you can also use the another formula, lambda cube minus summation d lambda square plus summation md lambda minus determinant of A equals 0. Here, if the order is 3 cross 3, the first term is lambda cube. Next, summation of D is the sum of the diagonal elements in the given matrix, and the summation of MD is the sum of minor of the diagonal elements in the given matrix, and the last one is the determinant of the given matrix. So using this formula, you can find determinant of A. Then on solving this cubic equation, you will get the eigenvalues, that is lambda 1, lambda 2 and lambda 3. These are the eigenvalues. Since the order is 3 cross 3, you will get the 3 eigenvalues, lambda 1, lambda 2 and lambda 3. Then you have to find the eigenvectors to the corresponding these eigenvalues using this system of linear equation A minus lambda I of x equals 0. By applying the cross multiplication, you can find the eigenvectors to the corresponding matrix, to the corresponding square matrix A. So these are the procedure. The next problems. Next, the first problem. Find the eigenvalue and the eigenvectors of the given square matrix of order 3 cross 3. It is 8 minus 6 2, minus 6 7 minus 4, 2 minus 4 and 3. So the first procedure, you have to consider the characteristic equation. The characteristic equation is lambda cube minus summation of d lambda square plus the summation of the minor of the diagonal elements lambda minus determinant of A equals 0. Let us find one by one. The first one, summation of d. It is the summation of all the diagonal elements. So these are the diagonal entries. So take the summation of all these 3. So it is 8 plus 7 plus 3, you will get 18. So the second one, the summation of the minor of the diagonal elements. So this is the first entry, delete this row and column, take the determinant of the remaining term. So the minor means you have to consider the determinant. It is 7 minus 4 and 3 plus. So the second term, so there is a diagonal entry, delete this row and this column, take the determinant of the remaining term, it is 8, 2, 2 and 3. So the third one, so this is the diagonal entry, delete this row and column, take the determinant of 8 minus 6 and 7. So take the determinant. So the first one, it is 21 minus 16. Second one, It is 8 into 3, 24 minus 4. Third one, 56 minus 36. So on solving, you will get the first one is 5, the second one 20, and the third one is also 20. You will get the 45 is the answer. Then the third one is the determinant of A. So find the determinant to the given square matrix of order 3 cross 3 using your calculator. You will get the determinant of A equals 0. Next, substitute the summation of D, summation of MD and the determinant to the equation star. You will get substitute in equation star. So the first term is lambda q, second term it is 18 lambda square, the third one 45 lambda minus 0 equals 0. So solve this, take the lambda outside, lambda square minus 18 lambda plus 45 equals 0. Or solve this equation, the cubic equation in your calculator, you will get the roots. The first one is 0, the second one 3, third one 15. So these are the eigenvalues of the given square matrix of order 3 cross 3. Next, you have to find the eigenvectors to the corresponding eigenvalues 0, 3 and 15 by considering the system of linear equations. So the next, consider the system of linear equations that is A minus lambda I of x equals 0. So consider the matrix A, take the subtraction of the lambda is a scalar and the identity matrix, multiplication of x is, x you have the 3 variables, x, y and z. So write the first A minus lambda I. So the given matrix is A minus lambda, first one, minus 6 and 2 is the next one, minus 6, 7 minus lambda, it is minus 4, 2 minus 4 and 3. This matrix multiplication of given variables x. So I take the 3 variables x, y and z. So equate this to 0. Then take this matrix multiplication, the row into column. So the first one you will get 8 minus lambda of x, second one minus 6y plus 2z equals 0. This is the first equation. Second one minus 6x plus 7 minus lambda of y minus 4z equals 0. The third one, it is 2x minus 4y plus 3 minus lambda of z equals 0. So these are the system of linear equations. Then substitute the eigenvalues to the system of linear equations. Then solve that, you will get the corresponding eigenvectors. So I will write this step by step. The first one, the case 1, put lambda equals 0. So put lambda equals 0 to the given system of equations. So the first one, you will get 8x minus 6y plus 2z equals 0. The second term, minus 6x plus 7y minus 4z equals 0. Third one, 2x minus 4y plus 3z equals 0. So consider the two equations, any of the two equations. So I consider the first and second one. On cross multiplication, you will get the corresponding eigenvector. So I will tell you the procedure. First I consider these two. So write the x variable. For x, except this, you have to write the determinant for the remaining term. It is minus 6, 2, 7 and minus 4. So using the cross multiplication method, so I find the x, y and z values. So the first one, x denominator. So delete this one, determinant for the remaining terms. Similarly for this y term, so I just write minus y, this is the procedure. So delete this, take the remaining terms 8, 2, minus 6 and minus 4. The third one, z divided by, delete this. So 8, minus 6 and 7. Then solve this, x divided by 24 minus 14, you will get the answer as 10. Second one, minus y. So it is minus 32 plus 12, you will get the minus 20. Third one, z divided by 56 minus 36, you will get the 20. So you can reduce this term. So multiply by 10, you will get x by 1, then y divided by 2 and z divided by 2. Therefore, you can write the x1 equals, the first entry is 1, second one 2, the third one is 2. So you have to write this in a column. So I take the transpose. This is the eigenvector to the corresponding eigenvalue lambda equals 0. Similarly, you can find the eigenvector for lambda equals 3 and 15. Next, for lambda equals 3, substitute lambda equals 3 here. You will get the first equation, it is 5x. The second one, minus 6y. Third one, 2z equals 0. Similarly, minus 6x, lambda equals 3, you will get the plus 4y. Then minus 4z equals 0. The last one, 2x minus 4y. Put lambda equals 3, you will get the 0, the last one. So consider any of the two equations. I consider the last two equations. So the first one, x divided by, delete these two, take the determinant. So y coefficient is 4, z coefficient minus 4. Here minus 4, z coefficient is 0. Similarly, the second one, minus y divided by, so delete this term, minus 6, minus 4, 2 and the z coefficient is 0. The last one, z divided by, so here delete this and the z coefficient is 0, minus 6, 4, 2 and minus 4. So this implies the x divided by, the first one, minus 16, 0 and minus 16. The second one, minus y divided by, it is plus 8, 0 plus 8. Last one, z divided by, you will 24 minus 8, you will get 16. So this implies the reduced form of this. So we will get the minus 2, y divided by minus 1, z divided by 2. Therefore, the second eigenvector, the x2 equals minus 2, minus 1 and 2. So you have to write this in column. So I take this transpose. This is the eigenvector for the lambda equals 3. Similarly, for case 3, lambda equals 15. So put lambda equal to 15 in this equation. So we will consider any of the two equations and solve that. You will get the another eigenvalue similar to the case 1 and case 2. You can solve that. You will get the corresponding eigenvector 2, minus 2 and 1. This is transpose. This is the eigenvector for lambda equals 50. So these are the methods to find the eigenvalues and the eigenvector to the corresponding given matrix. So next problem. So the second matrix, you have to find the eigenvalue and the eigenvector to the corresponding matrix. So the first one, first you write the characteristic equation. The characteristic equation is lambda cube minus summation of d lambda square plus the summation of md lambda minus the determinant of A equals 0. So the first one, the summation of d is the sum of all the diagonal entries. It is 7 plus 6 plus y, so you will get 18. Next, the summation of the minor of the diagonal entries. So the first one, this is the diagonal entry, delete this row and column, take the determinant for the remaining term, minus 2 and 5. The second diagonal entry is 6, delete this row and column, take the determinant of the remaining terms, 0 and 5. Third one, this is the diagonal entry, delete this row and column, the determinant of 7 minus 2 and 6. So take the determinant and add all three values, you will get the answer. So the first one, 30 minus 4, you will get the 26. The second one, it is 35. Third one, 42 minus 4, you will get the 38. So you will get the summation of the minor entry is 99. Then the determinant of A, calculate the determinant of A in your calculator of order 3 cross 3, you will get the determinant of A is 162. Substitute these values in the equation star, you will get the characteristic equation. So the first one, lambda cube, the second one, it is 18 lambda square, third one, plus 99 lambda minus the determinant of A is 162 equals 0. Then calculate this cubic equation in your calculator. You will get the three roots, that is 3, 6 and 9. Then to find the eigenvectors, consider the system of linear equations. Then substitute the lambda equals 3, 6 and 9 to the corresponding system of linear equation. Then solve that by cross multiplication, you will get the eigenvectors. So write this step by step. Next, consider the system of linear equations. So the first one, that is A minus lambda I of x equals 0. Since it is 3 cross 3 matrix, for x I take the three variables x, y and z. So the first one, so I write it directly, 7 minus lambda of x. Second one, minus 2y. Third term is z is 0 equals 0. Similarly, it is minus 2 into x plus 6 minus lambda of y plus, or negative sign you have, minus 2z equals 0. Third one, x variable is 0, minus 2y plus 5 minus lambda of z equals 0. So these are the system of linear equations. Then consider the case 1, put lambda equals 3. So the first one, 4x minus 2y equals 0. The second equation, minus 2x plus 3y minus 2z equals 0. Consider any of the two equations. I consider the first and second term. So in that, so using the cross multiplication method, for x, delete this. So y coefficient is minus 2, z coefficient is 0. See here the y coefficient is 3, z coefficient minus 2. Take the determinant of this. Next, minus y divided by, so delete the y coefficients, take the z and x and z coefficients -2 and -2. Next, z divided by, delete the z coefficient, I consider the x and y coefficients. It is -2, -2 and 3. So on solving this, you will get the first one, x divided by, so it is minus into minus, you will get the plus, so you will get the 4. The second term, minus y divided by -8. Third one, z divided by 12 minus 4, you will get it as 8. On simplify, you will get the x divided by 1, y divided by 2 and the z divided by 2. So, the first eigenvector for lambda equals 3, it is 1, 2 and 2 transpose for lambda equals 3. Similarly, the case 2, put lambda equals 6 to the system of linear equations, to this system. So, the first one, you will get the x minus 2y. So, I consider the first and second equation only. So, you can consider the third equation also. So, 6 minus 6, you will get the 0, minus 2z equals 0. So, the first one, x divided by, consider the y and z coefficients, -2 in the first equation, z coefficient 0. Second equation, y coefficient is 0, z coefficient -2. Similarly, the second term, minus y divided by, consider the x and z coefficient 1, 0, -2 and -2. Third one, z divided by, consider x and y coefficients, so -2 and 0. So on solving, you will get the first one, 4 minus 0. The second one, minus y divided by -2, the cross multiplication. The third one, it is 0 minus 4. So on solving, you will get the x divided by 2, y divided by 1, z divided by -2. So the second eigenvector for lambda equals 6, it is 2, 1 and -2 transpose for lambda equals 6. Similarly, case 3, for lambda equals 9. So I substitute the lambda equals 9 into first and second equation. First and second equation. So, you will get the first one, minus 2x minus 2y equals 0. The second one, minus 2x, 6 minus 9, you will get the minus 3y minus 2z equals 0. Next, using the cross multiplication, first one, consider the y and z coefficients, get the -2. Second one, minus y divided by, consider the x and z coefficients, -2, 0, -2 and -2. Third one, z divided by, consider the x and y coefficients, -2 and -3. So, solve this. The first one, 4 minus 0. The second one, minus y divided by 4. Third one, z divided by +6 and -4. You will get the 2. So, reduce this, x by 2, y by -2, z divided by 1. So, the third eigenvector, it is 2 minus 2 and 1 transpose for lambda equals 9. So, the eigenvalues are the 3, 6 and 9 and the corresponding eigenvectors, that is x1, x2 and x3. The next problem. So, the next problem, you have to find the eigenvalue and the eigenvector to the given matrix. As usual, first you consider the characteristic equation. that is lambda q summation of d lambda square summation md lambda minus determinant of A equals 0. So the first one, this summation of the diagonal entries, you add the diagonal entries 1, 5 and 1. So you will get the 7 is the answer. Next, the summation of the minor of the diagonal elements. The first one, this is the diagonal entry, delete this row and column. It is 5, 1, 1 and 1. The second one, this is the diagonal entry, delete this row and column. It is 1, 3, 3 and 1. The third one, this is a diagonal entry, delete this row and this column. It is 1, 1, 1 and 5. Next, solve this. The first one, 5 minus 1, cross multiplication, 5 minus 1, you will get the 4. Second one, 1 minus 9, you will get minus 8. Third one, 5 minus 1, you will get the plus 4. So, you will get the minor of the diagonal elements is 0. Similarly, solve the determinant, that is find the determinant in your calculator. You will get the determinant of the given matrix is minus 36. Then substitute this in an equation star. You will get the cubic equation lambda cube minus 7 lambda square. The minor entry is 0. The last one, determinant of A is 36. So we will get the cubic equation lambda cube minus 7 lambda square minus 36 equals 0. Solve this in your calculator. Solve the cubic equation in your calculator. You will get the answer. You will get the roots minus 2, 6 and 3. These are the eigenvalues to the given matrix. Next, you find the eigenvectors by considering the system of linear equations. Next, consider the system of linear equations, that is A minus lambda I of x equals 0. So, similar as the previous problems, I directly write this 1 minus lambda of x plus y plus 3z equals 0. Similarly, second one, x 5 minus lambda of y plus z equals 0. Third one, 3x plus y 1 minus lambda of z equals 0. So, to find the eigenvectors, consider any of the two equations. I considered the first two. So, the case 1, put lambda equals minus 2. So, the first equation is 3x plus y plus 3z equals 0. Second one, x plus 7y plus z equals 0. Solve this equation by using the cross multiplication method. The first one, determinant of 1, 3, 7 and 1 minus y denominator. So, delete this, write the coefficient of x and z, it is 1 and 1, z divided by, write the coefficient of x and y. So, the first one, 1 minus 21, you will get the minus 20. Second one, 3 minus 3, you will get the 0. The third one, it is z divided by 21 minus 1, you will get 20. So, in reducing this, you will get the x divided by minus 1, y by 0. This is only the x, y and z values, z divided by 1. So, the first eigenvector x1 equals, it is minus 1, 0 and 1 transpose for lambda equals minus 2. Similarly, case 2, put lambda equals 6 in the system of linear equation. So 1 minus 6, you will get the minus 5x plus y plus 3z equals 0. Second one, x 5 minus 6, you will get the minus y plus z equals 0. The same as the case 1. So the first one, x divided by, write the y and z coefficients, minus y divided by 1 and 1 and z divided by minus y 1, 1 and minus 1. So it is x divided by 1 minus of minus, it is plus, 1 plus 3 is 4. Second one, minus 5 minus 3, you will get the minus 8. Third one, it is 5 minus 1, you will get the 4. On reducing this, you will get the 1, y divided by 2, z divided by 1. So the corresponding eigenvector, it is 1, 2 and 1 transpose for lambda equals 6. Next, case 3. For lambda equals 3, so the system of linear equations, the 1 minus 3 is minus 2x plus y plus 3z equals 0. Next, x 5 minus 3 is 2y plus z equals 0. So using the cross multiplication, first one, 1, 3, 2 and 1. Second one, it is minus 2, 3, 1 and 1. Third one, minus 2, 1, 1 and 2. So on solving, 1 minus 6, we will get the minus 5. Second one, minus 2 and minus 3, we will get the minus 5. Z divided by minus 4 and minus 1, we will get the minus 5. So on reducing this, we will get x divided by minus 1, y divided by 1 and z divided by minus 1. So the third eigenvector, it is minus 1, 1 and minus 1 for lambda equals 3. And these are the analytical methods to find the eigenvalue and the eigenvector to the given square matrix. Next, I am going to explain the next method. This method is also called the numerical method to find the largest eigenvalue and the corresponding eigenvector. The method is called the Rayleigh's power method. This is an iterative method used to determine the largest eigenvalue or the dominant eigenvalue and the corresponding eigenvector in the given matrix. And you know the equation, that is Ax equals lambda x. A is the square matrix, lambda is the scalar, x is the non-zero column matrix. This is the system of linear equation. But in the Rayleigh's power method, we use the matrix multiplication with the initial matrix that is given in the problem. The first problem, given the matrix of order 3 cross 3, this is the matrix, and the initial matrix is 1, 0 and 0. So this method, in this problem, you have to find the largest eigenvalue and the corresponding eigenvector. First, you have to take the matrix multiplication of the matrix A and the initial matrix. So the first one, it is A x of 0, this is the first iteration. So write the matrix A, 2, 0, 1, 0, 2, 0, 1, 0, 2. Next, the initial matrix 1, 0, 0. So calculate this in your calculator. First one is the matrix of order 3 cross 3. The second one, 3 rows and 1 column. It is of order 3 cross 1. So we will get the answer 2, 0 and 1. So in the resultant matrix, you have the largest, see the largest entry. So you have 2 is the largest entry. You can take the 2 outside. So write the 2 outside. So the first you will get as 1. second one 0 divided by 2, you will get the 0. Third one 1 by 2, you will get the 0.5. So this term is the lambda of 1 and the corresponding vector and the corresponding matrix is x of 1. Again, you take the matrix multiplication of A with x1, the first iteration. So you will get the another matrix A x of 1. So write the matrix A, it is 2 0 1, 0 2 0, 1 0 and 2. The first iteration matrix 1 0.5. So you will get the first one 2.5, the second term is 0, the third one it is 2. So in this the large entry is 2.5, so keep it outside, take this as the common factor. So the first term you will get 1, second term, third one 2 divided by 2.5, you will get the 0.8. So you equate this, this is the lambda of 2, x of 2. So the next one, again you take the matrix multiplication of A and x with the second iteration. So the first one it is 2 0 1, 0 2 0, 1 0 2 with the column matrix 1 0.8. Calculate, you will get the column matrix, it is 2.8 0 2.6. In this the 2.8 is a largest entry, so take that as a common, 1 0 2.6 divided by 2.8, you will get 0.93. So fix 2 decimal places in your calculator. So it is lambda of 3 x of 3. So the next matrix multiplication Ax with the third iteration matrix, it is 2 0 1, 0 2 0, 1 0 2. The third iteration matrix 1 0, it is 0.9286. 0.9286. Then take the matrix multiplication, you will get the 2.9946. The second entry is 0. The third one, it is 2.97. So in this, the 2.9946 is the largest entry. So take that as common factor. So the first one you will get 1, the second one 0, the third one 0.9946. So this is the lambda of 4 x4. I stopped till this because, so here you got the 2.8, the next term is the 2.99. You can approximate those to 3. So I just conclude this. So the largest eigenvalue is 3. You can take the one more iteration, or else you can take the one more iteration. You will get the 3 as the eigenvalue. So I stopped till this. Therefore, the largest eigenvalue lambda equals 2.9946 is approximately 3, and the corresponding eigenvector x equals, you have to write in a column matrix, that is 10.99. This approximately 101. So this is the largest eigenvalue and the corresponding eigenvector. So in the next problem, they given the matrix A and the initial matrix 1 0 0. So you have to find the largest eigenvalue and the corresponding eigenvector by using the Rayleigh's power method. The first one, So you write the matrix multiplication, the matrix A with the initial matrix. So write the matrix A, it is 25, 1, 2, 1, 3 and 0, 2, 0 and minus 4. Next 1, 0 and 0. Then write the matrix multiplication. You will get the entries 25, 1, 25, 1 and 2. So in this entry, the 25 is the largest one. So you take that as a common factor. In the first one you will get 1, second one, 1 by 25, it is the 0.04. Then 2 divided by 25, it is 0.08. So I take the 25 as the lambda of 1 with the first iteration. Next, again take the matrix multiplication of A and the x with first iteration. So it is 25, 1 and 2, 1, 3, 0, 2, 0 and minus 4 with the column matrix 1.04, 0.08. Calculate this, you will get the first one 25.2, it is 1.12, then 1.68. So in this, the 25.2 is the largest entry. Take that as the common factor 25.2. So the first one you will get 1, second one 0.04, that is 1.12 divided by 25.2. Third one 1.68 divided by 25.2 will get the 0.07. So this equals lambda of 2 and the second iteration matrix. Again you take the matrix multiplication A with x of 2, it is 25, 1 and 2, 1, 3, 0, 2, 0 minus 4 with this matrix 1.04 and 0.07. Take the matrix multiplication, you will get the 25.18, 1.12, 1.72. So in this, the 25.18 is the largest entry. To take this as a common, the first term is 1, the second term it is 0.04, third one 0.07. So I keep this as lambda with third iteration, x with third iteration. Again take the one more matrix multiplication, A into x with third iteration. So it is 25, 1 and 2, 1, 3, 0, 2, 0 minus 4. It is 1.04, 0.07 equals. So take the matrix multiplication, you will get the entries same as the previous one. It is 1.12 and 1.72. So in that the largest entry is 25.18. So we will get the first term is 1, second and the third one is 0.07. Since the previous one and this term, these entries are same, so I conclude that the largest eigenvalue is 25.18 and this is the corresponding eigenvector. So lambda equals 25.18, you approximate this to 25 and the corresponding eigenvector are just right in a row, it is 1.04 and the 0.07 transpose. This is the corresponding eigenvector. So in the next problem, They given the square matrix of order 3 cross 3 and this is the initial matrix 1, 1 and 1. The first case you have to take the matrix multiplication of the matrix A and the initial with the initial matrix minus 2, 3 and minus 1, 2, minus 1 and 3 and the initial matrix. Then you will get the matrix. So the first calculate this in your calculator, you will get 6, 0 and 4. In this 6 is the largest entry, you keep it outside. That is, you take that as a common term. The first term is 1, second term is 0, the third one is 0.67. So keep this as the lambda of first iteration, x of first iteration. Same the second one, take the matrix multiplication of A with x of first iteration. So it is 6, minus 2 and 2, minus 2, 3 and minus 1, 2, minus 1 and 3 with this x with first iteration 1, 0 and 0.67. So you take the matrix multiplication in your calculator, you will get the answer 7.34 minus 2.67, next 4.01. Fix to 2 decimal places in your calculator, you will get these answers. Next in this, the 7.34 is the largest entry. So take that as the common term, the 7.34. So in the first one, you will get 1. Second one, minus 0.36, that is minus 0.67, minus 2.67 divided by 7.34, minus 0.36. Next one, 0.55 you will get. So take this as lambda 2 x of second iteration. Next again write the matrix multiplication A with x with second. So it is 6, minus 2 and 2, minus 2, 3 and minus 1, 2, minus 1 and 3. So it is 1 minus 0.36, 0.55. Take the matrix multiplication. So we will get the first entry, it is 7.82. The second one, minus 3.63, 4.01. So in this 7.82 is the largest entry, keep it outside. You will get the 1 in the new 1 as the first term, second 0.46, the third one 0.51. So it is lambda third iteration with x of 3. Next again x of 3. So it is 6, minus 2 and 2, minus 2, 3 and minus 1, 2, minus 1 and 3. So 1 minus 0.46, 0.51. So take the matrix multiplication. You will get the 7.94 minus 3.89 and 3.99. So in that the 7.94 is the largest entry. Take this as the common term. You will get the 1.49 is the second one, 0.5 is the third one. So you represent this, it is lambda with fourth iteration x of 4. Since you will not get the same values of the lambda, you take the one more iteration. It is a of x with fourth iteration. So it is 6, minus 2 and 2, minus 2, 3 and minus 1, 2, minus 1 and 3, 1 minus 0.49 and the 0.5. You take the matrix multiplication, you will get the 7.98. You will get the 7.98 and the minus 3.99 and the 3.99. So in this 7.98 is the largest entry. You take that as a common term. The first term you will get 1, second term is minus 0.5, third one is plus 0.5. It denotes this by lambda of 5 with xy. Go on, continue like this. You will get the one more matrix multiplication, that is A of x of 5. You take the matrix multiplication. Similar as the previous term. You will get the entries 8, minus 4 and minus 4. Here 8 is the largest entry. You will get the first one is 1, second one minus 0.5 and the third one is plus 0.5. So you denote this by lambda of the 6th iteration and x with 6th iteration. And since in the previous term it is 7.98 and it is 8. So both are approximately same. So you can conclude that the largest eigenvalue is lambda equals 8 and the corresponding eigenvector, it is 1, minus 0.5 and 0.5. So these are the procedure to find the largest eigenvalue and the eigenvector and the corresponding eigenvector using the Rayleigh's power method. Thank you.